Welcome to the UWEE Colloquium speech series. Okay, I'm General Huang, Associate Chair for UWEE Department. This morning, I'd like to introduce one of our good friends, Dr. Walter Sun from Microsoft, to give us a very interesting talk about the Bing, the search engine. Walter got his master and the PhD degree from MIT. In between the master and the PhD, he also worked for several different companies. For example, as a financial analyst in BlackRock, also as a software developer for Apple, and also for 2While. After his PhD, he joined Microsoft since 2005 and has been working there, specifically using machine learning technique for a lot of the Microsoft product. Right now, he's working on this Bing Predict. So let's welcome Dr. Sun for a wonderful talk.
Thank you, Dr. Huang, for the introduction, the invitation, and the opportunity you've given me to share what my team and I have done with Bing Predictions. As you mentioned, I've been at Microsoft the past 10 years. I started in codecs, so working on video, audio codecs. And in the last 7 years, I've been in Bing, working mostly on multimedia search and then as well as web search. More recently, within the past year, we started this new initiative called Bing Predicts. And I'll talk today about a little bit about Bing.com and then motivate how we move this into Bing Predicts. And I can answer questions at the end. The idea, I guess, is that Bing.com has a lot of technologies and algorithms that we use which can be leveraged for other things, solving these big data problems that you'll see we do for Bing Predicts. So the key after we figured out what we're going to invest in this is to figure out what are the topics people will find interesting. And that's kind of the next step we'll talk about. And when I get to that point, I'll discuss the different areas that we're doing now. Like I mentioned, we launched this about 8 months ago. We started with TV voting shows, mostly because popularity-based events work very well with web activity in terms of predictivity. And after we made that work, we tried some other areas which are a little more difficult, looking at matching what players would get drafted by which teams in the NBA draft. And then we moved forward into sports predictions, where we've done the World Cup and then the NFL season that's going on right now. In addition, we've also looked at other categories, like politics. We did the Scottish referendum, which is in September of this year. It was a vote to see whether Scotland would become independent from Great Britain. And then we also did the midterm elections. So as I mentioned, my primary job is in working on ranking in Bing. And the question, I guess, to maybe make it interactive to start with is, if you use a search engine, your favorite search engine if it's not Bing, what do you expect when you query hawks? If you type in hawks in your search box, what would you be looking for? What do you think someone would be looking for? Anybody? Okay. Wikipedia page explaining the bird. That's probably the best intent, right? Anything else? Anybody?
Seahawks.
Seahawks. So we're here in Seattle, so good guess. So Seahawks would probably be a good intent, right? The next thing is people will probably be interested in Seahawks. There's also, it's NBA season. There's a sports team in Atlanta called the Hawks. There's also a hockey team in the Midwest known as the Chicago Blackhawks that are also referred to as the Hawks. There are also other intents. There's things like, there's a movie in 1988 called Hawks. I didn't know about it until I tested this query, but apparently there's a resort called Hawk Creek, and there's a TV broadcaster, a former player, baseball player named Ken Harrelson, who's known as the Hawk. So just to give you an idea, when you query something as specific as non-specific as Hawk, there could be a lot of different intents. And beyond all these different intents, there's also the idea of temporality. So even if you're interested in one of these topics, like I'm an Atlanta Hawks fan, I might be interested more in how they've been doing recently. So besides looking at the Hawks.com or NBA.com Hawks page, I'm actually more interested in looking at, did they win last night or did they win their most recent game? So the idea of ranking is the idea of finding the intent of what people want and also determining if there's temporality in it. So how do we do this, right? The question is, if you think about this, the exact number of documents on the web is not agreed upon, but most people say it's over 1 trillion. So really the question is, how do you determine the top end results given 1 trillion different possible documents, right? In this example, the query was Hawks. How do you find the top, let's say, top 10 best ones? What we look at is the idea of relevance. The word relevance basically means, how well does a given document satisfy a person's need? Like, for instance, the wiki page on Hawks, is that the best document you can show for the query hawks. And maybe it is, maybe it isn't. So we built a model, a mathematical model, which we call our relevance model, which basically maps human notion of relevance to values. And the reason we want to do that is because we want to optimize that, maximize the cost or the reward function to get documents by some order that maximizes user preference. Since you guys are in engineering, you probably want to see the actual mathematics behind some of the top-level mathematics. The idea is probabilistic, right? I mean, you may know what you're looking for when you query hawks, but a person looking at another person, or I can't predict what you're looking for, right? So we have a probabilistic model that says, what is the relevance for a given query, right? So the idea is, what's the probability you want to show a document, let's say Seahawks.com, given that you queried hawks? And the idea is, if you've taken a probability class, you're familiar with Bayes' law. So the probability of a document given a query is equal to the probability of a query given a document times the probability of the document divided by the probability of a query. Well, we're examining a particular query, so 1/4 probability of the query is considered constant. So effectively, the relevance given this query is proportional to the probability of this query being issued given a document that you're looking for, times the probability of the document. And the reason why this is important is there's two terms, right? And one term is query independent. The probability of the document is basically how authoritative is this document. Example would be, let's say that intent was Seahawks. If I show you CNN.com versus Seahawks.com, CNN.com has higher authority. So the query independent feature is higher for CNN. But when you look at query dependence, if you're looking at a query that much better matches Seahawks.com over, let's say, CNN.com, the second term, the query dependent term, would kick in. And the idea is that you combine all these features and you want to order it by relevance. And the way we do it is through a machine learning method. Okay? So if you're familiar with machine learning methods, you basically provide computer systems a lot of training data and build a model to figure out the way to maximize a given reward function. So this is where Bing Predicts comes in. So the idea is that my team and myself, we've done a lot of work in terms of ranking using machine learning, and this technology is also applicable in other things. One area which I guess I thought was interesting is looking at all this information and doing other inferences. And the story behind how this started was that I mentioned the temporality aspect. Many years ago, I was in charge of putting together the first fresh ranking system in our search engine, which is basically making sure new results are properly shown when a query is new. And we did a lot of analysis. And one of the things that you notice is that, I can remember, January 15, 2009, a bunch of queries about US Airways came out, a bunch of queries about Hudson River came out. And you go on the website, CNN.com, you'll see pictures of this miracle landing, right? It was a feel-good story of that day where a plane heading from Newark to Charlotte, was coming to Seattle through Charlotte, had the engine knocked out, and the pilot landed the plane on the Hudson River, and no one died, and it was a great story. But before it happened, or as it was happening, you can actually see people searching for these events. What else you could do is you can also see, people, other things that happened. And 6 days later, the inauguration of Obama, January 21st, 2009, there were a bunch of inauguration queries before, during, and after. So you quickly could see that, people's query volume or spikes in queries highly correlated to activity that was happening. Well, what was more interesting, actually, during that same time period is that I was looking at a lot of queries that were coming up that were related to school districts. Like Lake Washington School District hit the #1 most queried query on Google Trends in late December of that year, 2008, and there was nothing going on. When I saw that query go up, I searched around because I was a bit concerned. I thought maybe there's some kind of event, good or bad, happening with Lake Washington, which is a school district in Redmond, and nothing happened, right? And over the winter, you saw it happen a lot with a lot of other school districts. You'd have Hennepin County, which is in Minneapolis, and eventually, the correlation was basically people were interested in knowing if there were school closures. So the idea was that even if there weren't school closures, and if there's no event, people would query it with the idea there may be an event, right? And the reason that people thought about that was because they watched the weather forecast the night before or days before and said, hey, there might be snow tonight, your kids might not be in school, so you need to figure this out, right? So the idea, it's not really a deep connection, I'd say, but the idea is just basic, the fact that people do things on the web and things because of other reasons, and you can infer this based off of looking at the data. And a lot of people are interested in this. And big data, I think that term is maybe overused today, right? But the idea is that there's so much data out there that people can make use of it. Over the holidays, I was just looking at this when I'm putting together a talk that someone said, big data knows when you're going to quit your job before you do. I don't know when I don't plan to quit my job, but I guess maybe I should check with Bing Predict and see if it can tell me when I'm going to quit. There was another story which is interesting, was saying that researchers can determine that in the first 90 seconds of looking at a new product, if you're searching on the web or actually in a store, color is the 60% influence. So basically, people have done some research saying, I've done a lot of data analytics and found that this is kind of the most important thing, right? So, I mean, I think maybe you all agree that big data is a kind of a popular catchphrase. If you don't believe it, I thought the best way to prove it is if people are actually doing plot lines about it. And I have a quick demo. I mean, it's just an illustration. There was a TV show on NBC called Blacklist, and one of their plot lines this season is about some hacker guy who does data analytics. And I just thought it was kind of interesting to show, relevant to say. So I'll show it to you here. The audio's not working. Audio.
Berlin has hired a skip tracer who calls himself Lord Baltimore.
2 months, and Reddington brings you a bounty hunter?
He's more than a bounty hunter. He's a statistician.
Even less impressive. What does he do? Find them with a slide ruler?
No. With data analytics.
You've heard of this guy?
Yeah. Lord Baltimore's an urban legend. They say he roams the deep web, hunting those who don't wish to be found. Uses some sort of collection algorithms to build a dossier based on the information that people give away online.
He's a data miner. Aram, can you pull up that file you showed me?
So I thought it was really funny that the protagonist, Elizabeth Keen, says with disdain, he's a data miner. I mean, like it's a bad thing to be. But the point, I guess, is, I mean, you can see that they have a bad guy out there who actually mines data and finds information about you, you know? So I think if these people in Hollywood are finding ways to incorporate this into their plot lines, I think it's kind of a mainstream thing. Anyway, so the main point, I guess, is that being able to extract a relevant part of data is science, which has a lot of value in a lot of areas. Sports is an area which I think is not a new thing. Every team that competes wants to find an advantage. You know, I've been doing, I guess, doing some analytics work for sports teams, college and pros, since I was in college. When I was in college at Georgia Tech, we would break down analog game films of our opponents and to figure out tendencies, right? And you think about how everyone does that now. And the difference is, in the old days, you had this VHS tape, actually it was Betamax tape, and you basically watch a film and kind of break information down. Today, the NBA has this thing called Sport View, where every moment, every motion of every player can be tracked for every second. So you have a ton of data now, right? And you can figure out if Kobe Bryant shoots better after he scratches his head or something, right? Something silly. But I mean, the point, I guess, is that you have a lot of data, you can make a lot of conclusions, but you need to make sure that they're significant conclusions, right? Like joking about Kobe Bryant scratching his head. That's probably not a real correlation, but maybe you will find out when he does scratch his head, he shoots better, but that's not really a correlation. That's just a coincidence, right? But there may be correlations where they've said, hey, people who catch and shoot do better than shoot off dribble, right? I've read a story about that. So there's things that actually are significant, there are things that are not. And the idea with big data is that you don't want to overfit what you're looking at. So anyway, that kind of motivates maybe big data and Bing predictions. That's just a text in case the video didn't work. So I'll talk about Bing Predict specifically. So we started, like I mentioned, about 8 months ago. We started with reality TV shows. The reason we picked those is because, as I mentioned, that user activity on the web highly correlates with their voting patterns. It's so powerful that even polling works worse than looking at activity. And you might think, well, that doesn't make sense. Well, actually, believe it or not, if you poll somebody, research has shown that people are biased. They don't necessarily tell you what they do, but what they think you want them to do, right? Even these reality shows is kind of funny. I tell people, I want to do some reality shows, and everyone kind of laughed and said, oh, no one watches reality shows. So I asked my coworkers, no one admitted they watched the show, but once you start doing it, everyone knows about it, right? So if you poll like a classroom, even you guys, how many of you watch American Idol? Or how many, the number of people who say they do is probably less than the actual number, right? And there's nothing wrong with it, it's just that people don't think that's something that college students should do, right? Graduate students should be studying or doing work. And so the idea is what happens on the web. Activity actually provides a better signal. And so we did Dancing with the Stars, we did American Idol, we did the NBA draft that I mentioned. We predicted, I'll mention later, 9 of the top 11 positions within one spot of the actual, which is on par with what ESPN and Sports Illustrated's analysts did. We did the World Cup over the summer. It got some attention because we had launched Cortana, which is our character on our Windows phone, and we had also gotten all of the knockout round games right, except for the consolation game. So that got a good bit of attention. The Scotland Independence was a nice play in Europe, mainly because I mentioned polling earlier. We had our online data was saying that the vote, which ended up being no by 55%, so it's 55-45 no to yes, we had a range from 51% to 59% through 2.5 months before the vote. A lot of the expert polling numbers were much higher and much lower. There's some numbers in the 70s. There's some numbers saying that the answer would be yes. And when initially we talked to some people about this in the press, they said, well, you guys are way off. I mean, it's either going to be like 70-80% or it's going to be a yes. And after it came out, they said, oh, wow, your numbers are actually more accurate than what people are polling. Because I think the reason why, if you're curious, is that there are many reasons, but two big reasons is that when they're polling people, a lot of people think that there's certain thing, the right thing or wrong thing to say, like I mentioned earlier, right? If you go to Scotland and say, hey, do you guys want to be independent? If a person is, if it's from BBC, someone from Britain, they might not feel like they want to answer the right way. So you might not get an honest response, whereas the stuff they're querying, stuff they're doing online, doesn't lie in terms of what they think. That's NFL football. I don't know if you can see it, this font's a little bit small. Most recently, we're doing the 2015 Bing Trends. So if you go to bingtrends.com, we predicted a bunch of events in 2015. I think it was interesting. I was talking to Professor Sun earlier, and he says that some of his researchers are doing work on predicting trends from publications, new topics. We kind of did the same thing for different things, more like things that general public care about, kind of like the fashions, NFL predictions. We actually predicted the Patriots, and we got some bad press or some kickback from the Seattle Times. But I guess I told them basically our computers don't have favorites, right? We have favorites. We know who we want to win, but based on our models, we had the Patriots going this year. So the press coverage, we've had over 2,000 stories in 6 months. Some of them organic, some of them kind of through interviews. But the interesting thing, I guess, is for most of these, if you track through the user logs, the fans who watch these shows, there's a lot of skepticism, and they'll say, oh, we don't think this is right. But then if we get it right afterwards, they'll say, oh, wow, actually, I was surprised, the predictions were actually correct, even though I thought there was no way it would be right. I think that's probably the best way you convert people into your technology. The people who believe you, they're good to have along at the beginning. But people who don't believe you, the ones that you convert over and say, hey, you didn't believe this would work, but now you're a fan of it, is kind of the best type of follower. We mentioned earlier we did the reality shows. The World Cup brought up a good bit of attention. I guess they're comparing us to Paul the Octopus, who was this octopus that allegedly was getting results right 4 years prior. This one. And then we talked about, in Europe, people were talking about our Scottish referendum vote. So I guess at this point, I've kind of told you what it is, if you had never seen it. The next part I want to talk about is how we do this, right? And thought this might be the more of an interesting part for the engineering audience. So I guess I'll first talk about how the voting shows work, in case you've never seen any of these shows. People, depending on their show, will either sing, like American Idol or The Voice. They'll dance, like in Dancing with the Stars, cook, or whatever they want to do, right? And what happens is judges will comment. Usually judges' comments don't count toward the scoring. It's just to help guide the public which way to go. I think Dancing with the Stars is the opposite, because they actually have a voting portion that counts as part of the judgment. And you see like Simon Cowell is famous because he makes these comments like, there's as much chance as you being a pop star, a rock star, as me flying to the moon tomorrow for breakfast. So you get these judges who are trying to kind of color the audience too, because they can't vote themselves. I mean, they don't vote in a significant way, so they want to help guide the fans. Then fans watch the show, then vote online by phone, or now online. There's a lot of different options. And each week, someone is eliminated. There's a danger zone, which is like bottom 3, bottom 2, depending on the show, elimination, and then you have a winner at the final week, right? So our goal is to pick the bottom end contestants, depending on the show, and then find a winner each week. I will mention one thing, that finding the bottom in a show where people are voting for the best, it's different from just finding who's the worst, right? Just so you understand. The idea, I guess, is that if you're voting for the best singer, and let's say you're the second best singer in everybody's book, you'll lose because you'll get 0 votes, right? So the question in each week isn't finding the person who's the worst, it's finding the person who's just not the best in people's minds, right? So it's a slight distinction, but it matters in our models. So as I mentioned, voting, the way voting works, user watches a show, you can go Facebook, like or dislike. And what happens is we found that voting correlates with their activity on the web, right? And as I mentioned earlier, people who go to certain pages, people who do certain things, if you're fans, right? If you're not a fan, if I tell you John Davis on some TV show got arrested for something, you might query John Davis just because you're curious. Oh, the reality show guy gets arrested or whatever. That doesn't mean he's going to win the show, right? It just means that you're curious about him. So you actually have to figure out the distinction between interest versus actual popularity in a singing. And the way machine learning works, is you find features that you think might fit, and the computer learns through the past what things work and what things don't. So the data sources we have, as I mentioned, is we have Bing logs, which is basically the queries that happen in aggregate, right? And web data, which is what people do. You say 8,000 people visited this page, 3,000 people are posting on this forum, people are looking at this video, 8,000 video views, 2,000 video views. These things are all signals that help learn whether or not a person is actually popular or not. We have public social data, fan page likes, tweets. We have some analysis engine which does sentiment, which says, hey, look, just because you tweet, we need to know if it's a positive tweet or a negative tweet. And I'll show you some examples to illustrate how that works. And then, plenty of standard public video sites that are very popular, especially for shows on TV, because singing shows, you can't really know how good someone is without kind of listening to the video if you haven't watched it. So those become very useful. There's also third-party data. Like I mentioned, some shows have judge voting, so we have to incorporate that into the models, obviously, because they incorporate in their models. So anyway, as I mentioned, it's a big data problem. There's millions of queries a week, as you guys, I'm sure, are aware of. Millions of tweets a week, which you guys, I'm sure, contribute to if you have your Twitter accounts. And there's petabytes of raw data. Right? So this is kind of where the engineering problem comes in, which what you guys are kind of probably most interested in is how do you take petabytes of data and make the best conclusions from that information? Web features. So we look at, for instance, this is American Idol. There's a page. Each contestant has a home page. Jenna Irene was a contestant this past season. You can see that, for her, you can see there's a video page, there's a contestant link page. There's information here about your interest in her. You can query. I mentioned it's not always the best signal, but you can also query a person. So you're saying, hey, I'm interested in Caleb Johnson, who's also another finalist in American Idol. And then there's a bunch of professional pages, right? This is MTV has a page which talks about the final between Caleb Johnson and Jenna Irene. So our systems have the ability to do document analysis and extraction of titles. And figure out, hey, this document talks about the top two, right? Even though maybe in this case it's not additional value because they're already at the final two, but just give you an idea how we do this, right? Sentiment-wise, on Twitter is really important, right? Because people can tweet, but you need to know what they're saying, right? And these are some samples, right? I mean, this one's positive, right? You're seeing Caleb Johnson's doing his thing, such a talent. I'm glad he has a talent like yours, right? You have negative ones like, what happened to My Majesty Rose? That song was way too big for her, right? So we need to actually have an algorithm which examines the text and determines whether or not it's a positive or negative sentiment. And we score it accordingly, right? A lot of other examples, you can sort of see for yourself, but most of them are clear. What's interesting is actually the algorithm can also pick more ambiguous one, right? I mean, for instance, look at the Jennifer Lopez one. She says, Jenna Escudo just killed it. So if you're not familiar with the language, you may not know if killing it is a good thing or a bad thing, right? Killing it, you can be in jail if you're killing something or somebody, but if you're talking about killing it and singing a song, that's a positive thing, right? So the algorithms have a little bit of, what's the word for it? A little bit of it's a little deeper in just looking for key matching words, right? Like positive and negative. They actually have to look at context too. There's another factor which you look at is just popularity over a season. It's probably no surprise to you that the popularities, there's a periodicity because that's the day of the show or day on the show. So every week there's interest. So you can look at things like, raw counts, which is important. You can look at the trend of certain contestants. Some contestants trend throughout the season, others are flat. You have a prediction of an expected popularity, right? And every day or every week when a new song performance happens, you may look at different things like, hey, there's a deviation. Far right, I'll show you that. Basically, something unusual happened. This person is considered the third most popular, but this week he's getting a big jump. You may look back at the show and find out this person actually had a great performance, and that actually contributes to his or her kind of bump in popularity. So what we do is we use a classification model. We use a logistic model, and we consider people who are possible elimination as 0 or 1 in classification. We label them as possibly eliminated or not. And we have basically different levels. You have elimination, which is perfect, meaning perfect for elimination. Danger, which is bottom 2, bottom 3, that's considered good, and then safe is bad. It's kind of a multi-point scale. We use this kind of scale for web documents. So that's the reason why we call it this way. We have to look at a bunch of features and look at features different parts of the season. Some features work at the beginning of the season, don't work in the later part of the season. So there's a temporal aspect of these models. And the way we did it, at least this is for American Idol, is we trained on 4 seasons, cross-laid it on a 5th, and then picked a ranker based off best, means, and minimums. And we swapped different parameters. and found that the rankers, which actually do ranking besides just a 1-0 classification, did better. So we relied on those instead. Okay? And then we have a separate model for social. So the feature selection is that we found that there's a significant effect on performance of models. So we used boosted decision trees, which is a type of learning algorithm. And we found, as I mentioned earlier, that performances in the initial few weeks of the season depend more than later in the season. And that probably makes sense, because at the first few weeks, you don't know who these contestants are. You actually watch the show, and you vote based off of what you see. But as you get past about the halfway point, the interesting thing is the people don't change their minds anymore. People come up with a decision, and it's probably the same. I think it's similar with politics, too. You watch a couple of debates. Once you've got an opinion, it's hard to change your mind. So what's interesting is no matter how much Ryan Seacrest, on American Idol says, your vote matters, you're watching the show, listening to it matters, a lot of people have decided by about halfway through the show what they're going to vote. So like I said, the model, we split the season into multiple parts, and then select features for each section. The output of the trained model is basically who's safe, who's going to be eliminated, and who's on top. And we have an answer in Bing.com that shows this. Our voting shows success is around the 90% range. It's better than the competitors. I think it's surprisingly interesting because if you think about it, when you're with 12 contestants left, you have theoretically a 1 in 12 chance of getting it right if you don't have any information right. So the information that you get to be able to get 90% accuracy includes early weeks and later weeks. Later weeks are easier. If there's 2 contestants less, there's a 50% chance you get it right, but in the early weeks, you have 1 in 12, 1 in 11, 1 in 10 chance of getting these right. The interesting story I'll share is American Idol. So American Idol this past season, the finale was in mid-May. And in late March, we had a model predict Caleb Johnson as the winner. And Caleb Johnson, he ended up winning. But what was most interesting, a couple of things interesting. This is what I have up here is the Vegas odds for the contestants. On the final day, even in the finale with only 2 contestants left, Vegas figured that Jenna, who was the person who ended up losing, was actually a favorite. And at a point where we knew Caleb was going to win, he was still a 12-1 underdog. So the point, I guess, is that Vegas is probably kind of a polling-based method, how people are wagering, whatever. You find that even up to the end, people think a certain person will win, where in fact that the online activity is showing the fact that the other person will win. And that was interesting because we basically knew 6 weeks in advance who the winner of American Idol would be, despite the fact that Vegas didn't think so. So that's popularity. Popularity in itself works really well for these type of predictions, just because user activity, as I mentioned, highly, highly correlates to voting patterns. But we decided to go further and look at other areas. We call wisdom of the crowd. The idea is that these are events that aren't dictated by popularity. The NBA has a draft every season, and the way the draft works is that you have a bunch of eligible amateur players, and then you have a bunch of teams that are looking for players to fill their needs. And the idea is that each team, come draft night in late June, gets to select 1 player and they go down the list. Okay, so it's kind of like a playground selection when you're playing as a kid or whatever. And the idea, I guess, is that there's nothing popularity can do. I can tell you I love this guy, but that doesn't make a difference, right? Each decision depends on a handful of people in the front office of these basketball teams. And even furthermore, this is even worse because these teams don't want you to know they want somebody. Suppose you have the 8th pick in the draft and there's a guy you really want, but the rumor is he's the 6th best player available. You're not going to get him unless you downspeak him. I say, I think this guy really, really, but John Smith is terrible. I don't think he's going to go in the first round. And you would do that in order to kind of bring down his stock to make him down to 8, right? So we were actually a bit worried at the beginning, thinking, well, our data may actually be negative. Our signals may show that people are actually, what they say may be negative. We actually didn't find that to be the case, but even if we did, the models could learn that, right? Machine learning models can say, take all this information that these people are saying and make it negative, right? But what we actually found instead was that the idea, the wisdom of the crowds or people who are related to the teams actually knew what the teams wanted and would post on it. You have sports writers, say Sacramento Kings sports writers would say, hey, we really need Joel Embiid or whatever. And the fact is, it would be a good fit for them. And indeed, those guys aren't going to play games. I mean, sports writers want to provide information to the people as true as possible. So what happened was, and even fans know, right? Fans says, we're missing a shooting guard for our team. We need to pick up another one. In aggregate, that information was pretty powerful. This is kind of some of the information you can see. You have the top right corner, some information. This Twitter site, people are talking about who the Sixers should pick. Looking at the bottom, one of the players was injured the week before the draft, so there was a lot of talks. We had to figure out if we can find online the signal to figure out how strong this injury would affect his position, right? So we had this model, and then we ended up, like I said, getting 9 of the top 11 picks within one position in the actual position, which means that the top 3 we got completely accurate, and then as we went down the list, it gets a little bit harder because as soon as you miss a position, there's the idea if you miss one, you'll miss another one, right? So anyway, we're pretty happy with the model. If you think about it, using a computer model, no human intervention, purely machine learned model, you got 9 of the top 11 picks within one spot. And like I mentioned, it was on par with what ESPN and Sports Illustrated's top analysts were doing. So then we moved over. That was the NBA draft isn't really sports in the sense that there's actually a slotting or matching game, right? Whereas sports prediction is actually pure sports, right? And this is a one-on-one competition or a two-on-one competition where you need to pick a winner. And what people think about things don't necessarily affect who's going to win, right? So what we did, though, is we started with Soccer World Cup, and we were doing predictions for each game, win, loss, and tie. And in the knockout round, which is there 16 teams playing, so there's 15 games to get to the final, we were able to get the correct winner for each of the 15 games. As I mentioned, we did miss the Brazil-Netherlands consolation game, but I think that was a big surprise because you can't really, it's really hard to model motivation, right, of consolation games because people sometimes don't bring in the full effort they have in a regular game. So that's part of the factors, right? But in statistics, I'll just explain to you. So the way the models work is you have kind of a prior model. A prior model is not social, it's not popularity, it's basically who's stronger, right? You need to have this because just because I like, let's say, the Atlanta Falcons doesn't mean that they're going to be the best team in football just because someone likes them. But so we come up with a prior model which looks at information about teams. You have scoring, you have margin of victory, you have past win-loss against each other, right? I mean, a lot of people do this. If you follow football, you watch Seattle's playing Carolina this weekend, which most of you probably know. Seattle's beaten Carolina each of the past 3 years, right? So those kind of factors are important in terms of making prediction. You look at playing surface. Are they playing on the same surface this time as they did last time? What are the weather conditions? And all these factors, right? And this provides kind of a prior strength model. If you look at NBA, I skipped the point, in the NBA draft, you actually have a prior model too, where people say, who are the best college players? And what they do in basketball is they have these things called like WARP, like wins above replacement player. So you project how many wins this guy will give you in the future, right? So that's kind of the prior model. And then you need to figure out how the matching works, right, based off of team needs, other factors. Same thing in football. You have a prior model, but then during the week things happen. Players get suspended, players get hurt. Weather conditions change. Oh, Lambeau Field will be 25 degrees this weekend. Is that going to impact people playing from Miami? These factors come into play. So, we look at, this is still, these factors are a statistical model, right? League position, points, I mentioned win-losing streaks, and then, you want to normalize by what's average at that time period. You look at other factors like historical performance, I mentioned, game level features, which week of the season. Some people perform well beginning, they're known to fade as the season progresses. So these features all factor into the statistical model. Then you go to the web and social features, which says, hey, people are tweeting stuff. And what's interesting is people always tell me, there's no way someone's tweet's going to affect the outcome of the game. And that's true, right? But what's interesting is if you look at things like late injuries, right? If you look at, for the World Cup, Brazil lost one player due to a couple of yellow cards, and a guy who's going to miss the semifinal. And the idea was because there was an injury, and all prior models don't fit into this, right? A guy who plays for a team helps them get to the semifinals of the World Cup. Then he gets hurt. Well, how do you factor that in? Surprisingly, the consensus model provides some signal, right? And what's interesting in different things, you find actually the biggest signal is when a fan of a certain team is actually not positive about their opportunity. So we had some examples where the Dolphins are playing someone, and there are a bunch of people in Miami area who are Dolphin fans are saying, oh, we can't win this game. These kind of factors are, surprisingly, an aggregate, provide some signal. So the models, similar to what we did for other reality shows, we do logistic regression, apply random forest, and boosted decision trees. And as I mentioned, there's so much data and there's so many models, you can actually overfit, right? I can actually fit any model to anything I want and say, I think the final score of the game this weekend will be something ridiculous, like 4-2 or something, right? Maybe your model does something so overfitting, right? You realize, well, in football, you don't really end up 4-2 scores very often, right? So then you have to create an ensemble and compute medians and means and make sure the parameters are selected properly. So that's sports and entertainment are two main areas we've done. The third area we entered is politics. We were asked by the folks in England to kind of look at the Scotland independence. For those of you who don't know about this, in September, Scotland had a choice to vote to see if they could be independent. The interesting challenge behind this was that, as I mentioned earlier, a lot of our work is based off of good training data, right? So American Idol has a show every season, NFL plays every season, World Cup is every 4 years. So you have plenty of training data. But independence votes aren't very common. Most people don't secede very often, and if they do, sometimes it's done by war, right? Like the Civil War we had, the United States seceded from Britain, 1700s. There was no vote, right? It was just a battle. But nowadays, they periodically have votes. And the challenge was that there wasn't a whole lot of training data, but what we did is we spent a lot of work looking at search terms and social terms that are pro against the independence. And the tricky part also was that people in Scotland could vote, but not other parts of Great Britain, right? So people in Great Britain would prefer that they stay in the Union, whereas people in Scotland had the preference maybe the other way, right? So we needed to be careful and carefully segment the data into people. These are potential voters. These aren't potential voters. And that's actually interesting because it happens even in our elections. You might think, well, in the U.S., everyone can vote, right? But in reality, children can't vote, right? And then there's some people who don't vote, right? And so you need to figure out a model where, based off of activity, is this potentially a voter? Whether it be, is this person underage, or is this person not a voter, or actually is this person a voter, right? Is this person saying a lot of things, so you don't want to overcount people who actually are just very vocal? As I mentioned, our models were between 51 and 59%. The final answer was actually 55%. We're pretty happy that it worked out that way. We had a bunch of people in Europe who were saying, oh, this is kind of silly that a computer can try to do this. And there's no way it's going to be something in the 50s. It's going to be 70% or something. So it was kind of nice to see after the fact that we did get something close to what it actually was. So that concludes my slides. I can definitely discuss any specific aspect you find interesting. These are the teams that we're working on. I've worked on predicts. As I mentioned, we've done it for 6 months or so. So we're looking at new areas that people find interesting. So if you have certain areas you think might be good prediction areas, we'd be happy to entertain and hear them too. Questions? Yes?
In respect to trying to analyze the drafts and predict them, can you predict trades between teams?
Yeah, that's good. The question is, while predicting the draft, can you predict trades? You're talking about trades before the draft, pre-draft trades, right? Yeah, that's difficult. I think that we were talking about this before the draft happened. What happens is, trades happen. Like there was a trade yesterday with Cleveland and Miami, 3-team trade yesterday. But before the draft, teams can trade their positions, which makes it a lot more difficult. We were trying to figure out if we could model that based off of rumors. And what we found out for this draft was that it was probably too difficult to do that. Like the probability, the only reason you actually want to enforce that is if you think the chance was greater than 50%. If it's less than 50%, you're more likely going to be wrong than not. So we found out that none of our models found any signal that was greater than 50%. So you're right. I mean, that one of the monkey wrenches into these things is that you might say, Philadelphia needs a big man. But if Philadelphia trades their pick, suddenly you're not going to get it right because the person that traded for Philadelphia is going to pick up the guy that they wanted. So yeah, that is a potential issue. But fortunately, at the very top of this year's draft, there weren't any trades, so it helped us, I think. Your question?
So can you make money off that? I mean, because if you can predict the outcome, so you can do that in the stock market.
Yeah. I think that question, since we're in the business of providing experiences for users, probably can't comment too much on it. But I think people could theoretically apply some of this information. In terms of, like I mentioned, the Vegas odds for the American Idol were different from what we thought. So I mean, there are opportunities, but we don't. Our job is just to show users some of these things that are interesting.
Are you going to try predicting the Oscars this year?
Yeah, we're doing the Oscars. We're doing the Golden Globes. So yeah, we'll be doing the Oscars in February next month. So stay tuned. If you guys haven't used Bing.com, hopefully this is. I'll tell you. Part of the reason we're doing this, part of the reason that I think they let me work on this is because it's a differentiator, right? I mean, we found that during the midterm elections, a lot of people came to Bing.com's site to look at the predictions because there's a lot of sites that talk about who's in an election, but I'm not a big political followers, so I don't have a good sense as to is the North Carolina Senate election going to be a landslide or not, right? So the night before, day before, I'll look at our predictions and say, look, these three races are going to be close, so I'll just follow them, right? Whereas without that prediction, you just have no idea. You can pick a race that's going to be 90-10, follow it all night, and realize, well, everyone else knew they're going to lose. So that's kind of one of the reasons that we're trying to pick new areas. But yeah, we're looking at other entertainment Oscars. We did what was that? We did the Emmys last year. We'll do the Oscars this year. Have any of you, out of curiosity, any of you heard of this? Any of you used it? Not many. So I mean, I think hopefully you could try it out. You can see if you find it interesting. And you know, if you have my contact, or Professor Wang has my contact. So if you have suggestions of other things that you think might be worth predicting for users, you know, I mean, in terms of not the making money aspect, because we're not in that business, but for web search, but for search engine, if we can provide information that users find interesting, and you know, we're happy to try different things. Other questions?
Any more questions? No? Okay, so let's give a big hand to Dr. Sun again.